So this is the main hall now called Hinsey Hall, and this is our fossil tree case. Now I picked on this in particular because it kind of encapsulates, in essence, what engineering is about in the Natural History Museum. So the specimens tend to come in like this, fairly neglected because they've been in our store for a long time. So first of all, conservation will condition report them and consolidate the surface. Because although this weighed over 2 tonnes, it's very fragile and friable, so it was quite a handful to deal with this. So next we did some photogrammetry scans and made a model of it. So this is the large tree you've just seen here. These smaller ones, we've got a very cheap scanner that we can do those actually in the workshop, but this one was done by our scanning unit for us. Once we've drawn up a CAD model of what it is we want to produce, then this was a separate workshop we set up just for this job because this workshop didn't have enough height. So Glenn, this is Glenn. Glenn made this clasp to fit around there. That's about 100mm wide by about 12mm thick, I think it was. So it's quite a chunky old mount, this one. And we used the press quite extensively on forming this shape around the trunk of the tree. After that, we then made this frame that you saw in the original CAD model. This frame is not only to lift it into position to the horizon, this is also for transporting as well. So you've got these extra bands to protect the tree while it's in transit. It also doubles up as a load spreader because we have an issue with the floor loading in Hinsey Hall. So we had to have this over 3 metres long to not exceed the floor loadings. After we'd made all the steel work, then the clasp is sealed in with EPOPAST, so it's an absolute snug fit on the specimen, so there's no fidget. Then it's transported to site to the case it was going to be installed in on skates. And then it's raised to the vertical, as you can see there. And fortunately, no bits dropped off the specimen when we raised it up, which was a big concern of mine. I lost a lot of sleep over what was going to happen when we put this vertical. This case was built by a German company called Raya, and I interacted with them quite a bit with CAD models so that we knew that the pieces would come together, because there was only 5mm clearance for this to fit in the case, so it had to be right first time. And then we just stripped away the transport frame after the clasp was bolted into the base of the case. Another item from the Hinsey Hall was this giraffe. Again, Glenn made the bulk of this. This you can see it in black there. He originally had that in like a nice cream colour, but the designers kind of wanted it to be differentiated from the bone, but I thought it looked better than cream personally. So that started off again as a CAD model, and then we do the layout of the frame where it mates onto the German built case again. And this is it in the workshop. Now the original mount was made in Victorian times, and it was very unstable. You could just push it like that and it would spring around with one finger, so we had to strip all the old mount out. And the old mount, a bit similar, I don't know if you all heard when they did the blue whale in the Hope, the main whale, the bones were all kind of bonded onto the original framework, so that all had to be dug out, but we weren't allowed to rebond the new steel, so we had to go for this two rod system to give us the rigidity and the mount that we needed, because this ultimately was just going to stand on 4 points, so it was got the potential to be quite flexible. That's the finished rib cage section of the mount. There again you can see the bracing inside that is mainly hidden inside the spinal column. And this is after conservation had fitted the bones onto the mount. And they had to 3D print the sternum there because the original sternum had deteriorated beyond practical use really. And this is it, the whole thing built up and installed. You can see how the steel follows quite closely the profile of the bones. This is 20mm solid section, so again we had to use the presses to get those bends to follow the contours of the bones so closely. And that is just, as I say, just held on four points on the base. This was another exhibition that we were running alongside, so we were designing and building this at the same time we were refitting the main hall. So we were quite stretched, and we had to sort of divide into two teams during this period, which I'll come on to in a minute. But this was a 6 metre long jawbones, a whale arch from a blue whale again. They came into the museum again, you know, just been in storage for years and years. They were originally installed in the front lawns back in the turn of the last century, but I don't think they've been on display since then. So we used photogrammetry to generate a 3D model of the bones, and then we could design this adjustable support come mount around the model of the bones. Now we designed these so that we could get the 2 points of the bones to line up perfectly. So these are left and right threaded. These were M24 threads on there, and you can turn this. It works like a turnbuckle. So you can turn this to jack it, either lengthen it or decrease the length as required to get the angles to meet up. These are standard genie lifts, so that gives you some idea of the size compared to the specimen. There it is partially installed. That's the finished exhibition. And this is a short film of us stripping it out after the exhibition was finished. It's a bit of a shame really, it was only in for 6 months. It was quite a lot of work. So we had to design a transport frame to get them back out of the building, because they were going out through a different door to what they came in, and they wouldn't fit on the old pallets that they came in on. So it's quite a lot of work just for quite a short period really. And this is the Thames whale. I don't know if you've seen in the news, you may or may not have done. There's a whale currently swimming around in the Thames. Well, this was a whale that got stranded in the Thames about 10 years back, and unfortunately it died, so it came to the museum, and it was the flesh was stripped off, and it's been kept for scientific purposes. Jules there, he was the main engineer working on this one, and as I mentioned, we were very pushed for time during this period, so we came up with a new solution for making this mount a lot quicker than we normally would. Normally we'd make a standard armature and weld all these fingers onto it in the appropriate places and form it and that, but we didn't really have time to do that. So we came up with this idea of making the standard kind of supporting framework you can see along that bottom piece there. And then what we did, we clamped the fingers in between this thinner section there. And we spaced the bolts so that every 2 or 3 fingers we could clamp them separately from the rest. So all these then became adjustable as we added the bones on. So it saved us a lot of time doing it that way. It was quite successful. It looks a little clunky in that photograph, but actually when you see it installed, it looks no different to any standard mount in actual fact. And these are a couple of flippers, one's from a blue whale, one's from a humpback whale. They're 4.5 metres high, those. So again, we started off with I use scanning quite a lot these days. I find it really helpful for especially stuff that you can't just pick it up and turn it over. And you can obviously manipulate it as a CAD model. So that enables us to design the framework before we even really got any contact with the bones itself. You can see there this framework was going to be raised to the vertical. This was just a supporting leg for transit, and it was unbolted when it was installed for display. And there you can see it raised to the vertical. It gives you some idea of the size. This is a special frame we made this for our conservation department, because there they'll show you there's a sunfish. And this is a type specimen, and it was in quite poor condition. So they had to do a lot of work on it. So we made this special jig frame so that they could rotate this thing around at any attitude so they access the specimen fully. But the problem here is it's not just us who have limited space, it's all the doors in here are not big enough. So we couldn't actually get it through any doorway in that configuration. So with this special mechanism there, it enabled us to to tilt that over at about 30 degrees, and then we could lower the whole thing down just enough to get diagonally through doorways. And that worked out quite well. That's now gone back into storage now for the scientific use. Next door we have a CNC router that is quite useful. You'll see that on the next talk. For those who don't know, we can draw a fancy shape in CAD, and then we can load this into this machine and it will reduce that precisely what we've drawn, which is quite handy on occasion. Although in the main we kind of use traditional methods in this workshop, because you can only cut up to aluminium on that particular machine, so it's got limited use for us as engineers. We don't just, as I say, we don't just do mounts, we look after the museum's animatronics as well, which is, there's a small Deinike there that has just been refurbished, and this is our big T-Rex that's on public display. This is currently being serviced at the moment, so you can see where we've cut into it there and into the belly and removed the tail. There's the tail line down there. And we have to do quite extensive cuts to get access to the mechanisms on this. You can see the size of it looks quite horrendous, but actually we've got techniques where we can restore the artwork, and it's very hard to detect where we've actually cut it open. So you can see that's a sort of cross-section inside it with some of the mechanisms in there. This predominantly runs on compressed air, and that's controlled by electro servos. So we have special valves that can drive these cylinders and give lifelike movements. We make all sorts of mechanisms for interactives. This is part of a mechanism for some bubble tubes in our Earth Treasury Gallery. And we have 3 different tubes of different viscosity silicon oil, and these drive cylinders that pump air bubbles into the base of the columns, and as the air comes up, because of the different viscosities of the oil, you get different sized bubbles. And it's quite a nice display there, actually. This is from our volcanoes and earthquake gallery. This is demonstrates the principle of a damped and undamped building during an earthquake. And the base there, you press a button, this base here oscillates backwards and forwards, and it demonstrates the difference between a damped and an undamped building. This again is from our volcanoes and earthquakes. This is shows what happens on a fault zone, and as your visitor turns the handle, you build up a stress in the Earth's crust, and then suddenly it releases, and there's another section there that rides up against that one, so it's like one plate running over another. And there's quite a clever mechanism in there that prevents people from driving the mechanism once that process is in operation. And this is a hand-generated seismic wave. So this is a 3-axis device that can move X, Y and Z to generate a graph so people can see what happens in a real earthquake. And that kind of gives you a broad idea of what we do down here. Like I say, we don't just do, there's a small range of some mounts we've made in the past, but we're at a stage at the moment where we're not doing a temporary exhibition, so we're not really mount making right now. But Jules down there is doing, we're refurbishing some display cases, and this is a new locking mechanism we've come up with, so you might want to take a look at that to see some of the mechanisms we make. And that's us really. Is there any questions?
So the mechanical engineering work that you're actually doing is actually at this point of time much more than the static mounts.
Yeah, we've always done a broad range of stuff. We tend to do the heavier mounts like this. Darren and his team, they tend to do the lighter, more delicate mounts, and anything sort of over a couple of kilos, I guess, is engineering tend to pick that up.
When you're making the mounts, when you're doing the contractors and whatever, do you manufacture and fit all of the operating mechanisms? You know, the pistons and the electronics as well, or do you get that?
No, it's all done in house.
You do that, yeah.
Yeah, we can write the ladders for the PLCs and that sort of thing.
How big is a team actually? How big is a team? in the engineering team?
There's 5 of us, so there's not many. There's a lot more designers than there is engineers.
It's never good.
There's- I think there's, what is it, 4 of you now, is it?
Full mount maker.